Good morning, class. So in this live lesson recording, we're going to be going over Unit 7, Lesson 8 notes, which is all about the volume of spheres. So in Lesson 7, we talked about the surface area, which if you remember, surface area is kind of like if we were to wrap up a ball and then unwrap the wrapping. That would be the surface area. The volume is everything inside the ball. It's like how much, like if you were, this would be kind of weird, but like let's say I have a ball water container, right? I think they make them for like Christmas time. They usually make like a Coca-Cola bottle that looks like an ornament, like a Christmas ornament. That would be like the volume. How much Coke is inside of that ball, right? So that's the volume. Everything inside of the sphere, how much space that takes up. So that is three-dimensional. So that is length, width, and height. So volume, and this is the formula that we're going to use. And again, I've said this like so many times in this unit, but the one thing that you want to pay very close attention to whenever you're trying to find the volume of something that's circular is typically a lot of times it'll give you the diameter. What we care about is the radius, not the diameter. So the formula is 4/3 pi r cubed. So that probably looks familiar. The pi r, normally it's pi r squared, right, for area, but for volume it's pi r cubed. Okay, so pretty simple formula. And we're going to plug it into Desmos and just keep reusing it. So I'm going to go in here and change the formula. So it is 4 divided by 3, that's 4/3, times pi, and we're going to use 3.14. There is a pi button here. We're just going to use, whoops, times. I forgot the times. So times 3.14 times, and then we don't know what our radius is, cubed. So we'll figure out what that is for our first one. Okay, so use the formula for the volume of a sphere to find the volume of a basketball that has a diameter of 9.2 inches. So we actually did this exact same question only for the surface area in lesson 7. All right, and then it says round to the nearest hundredth, so we'll keep that in mind. All right, so our formula is 4/3 times pi times the radius cubed. So in this case, the radius is half the diameter. If you don't know what half of 9.2 is, you could use a calculator. But half of 9.2 is 4.6. And we're going to cube that. All right, so our number here that I was waiting to do is 4.6 for a basketball. And then I'm going to raise that, so this AB button is how you raise it to any power other than squared. So if you want to square it, you do this, but if we want to raise it to anything number other than 2, then we'll hit that button. And then I'll change the number to 3. And now all I need to do to change my formula is the only thing that changes, the formula stays the same as the radius. So that's the only thing I need to change from now on. All right, and we're going to round to the nearest hundredth, so the number after the hundredth position is a 3, so we're just going to keep it as it is. So 4.0751, or sorry, 407.51. Said that wrong. So the volume inside of a basketball is 407.51. In this case, it is cubic inches. And that's it for number 1. Question number 2, it says find the volume of a sphere with a radius of 1.6 yards. Leave your answer in terms of pi. Okay, so this is where we're leaving the pi in the answer. Okay, so it is 4/3 times pi, so we're leaving pi in this case, times the radius squared, or cubed, I mean, 1.6 cubed. So basically what we're going to do for this one is we're just going to multiply this times this and leave pi in there. So it's going to be 4/3. So I am going to have to do another formula here. So 4 divided by 3 times, and then it's 1.6 was the volume of that one, or sorry, the radius of that one. So it would be 4. It said leave it in terms, it said round to the nearest hundredth, and then it says leave it in terms of pi. So 5.46 pi. And I said this before, but leaving it in terms of pi, I'm not really sure how that's useful, but that's what it tells us to do. Because in no circumstance would I ever tell somebody, yeah, the volume of this thing is 5.46 pi. That makes no sense. All right, but this is cubic yards. So 5.46 pi cubic yards. So all I did was I multiplied this part times this part and left the pi as pi. All right, how much air is needed to fill a basketball? So air is volume. How much air are we putting inside of it? All right, so this one has a bigger diameter than the previous one. So the other, or sorry, smaller. This one was 9.2 inches. This one is an 8.8 inch ball. All right, so basically we're just doing the same thing. Volume of a basketball. Just a smaller one than last time. Okay, so the formula is 4/3 times 3.14 times, in this case, the diameter is 8.8, so we want half of that, so 4.4 cubed. And that's it. So let's plug that back into our previous. I'm going to delete this one so I can go back to my previous formula. There we go. All right, and I'm just going to change the 4.6 to 4.4. And everything else is the same. And it says round to the nearest hundredth, so that would be here, and the number after the 3 is a 7, so I round up. So 356.64. 356.64, and in this case it is cubic inches. And that's it for that one. Okay, now this one, oh, interesting. Okay, so this one says a volume of a container measures this much and contains 50 marbles. Each marble has a radius of 2 millimeters. Use 3.14 as an approximation for pi. How much space in the box is unused? Oh, okay, interesting. So what we're going to have to do is we're going to have to figure out what is the volume of all these marbles and subtract that from this container to figure out how much is unused, how much of the volume is unused inside this container. So like, imagine you have a box, right? So a cube, and you dump a bunch of marbles in it, 50 marbles, right? And we're trying to figure out how much space you can fit inside that. So like, if you were to dump rice inside the marbles, like rice can fit in between the marbles, how much rice could you fill in there? Is kind of what that's asking. Although rice obviously is also not gonna perfectly fit. Like how much more water could we fit with those 50 marbles? That's kind of another way you could do it. But anyways, so we need to find out what the volume of one marble is, multiply that by 50 to figure out what the volume of all the marbles are, and then subtract that from the volume of the container. So the formula for the marbles hasn't changed, so it's 4/3, or sorry, volume. A marble is a sphere, by the way, in case you didn't know that. So 4/3 times 3.14, whoops, I forgot the 1, times 2, because that's our radius, cubed. Okay, so all I'm going to do is come back in here and change this to a 2. So each marble is approximately 33.49, we'll say 33.5. It's so close to 33.5, we're just going to leave it as that. Okay, 33.5 cubic millimeters. Okay, that's one marble. I need to multiply that by 50 to figure out what the volume of all those marbles are. So I'm just going to go down here, 33.5 times 50. That's 1,675. That's the volume of all the marbles. 1,675 millimeters cubed, or cubic millimeters. Okay, and then to figure out how much volume is left over inside this container, I just need to subtract. So 3,000, so the original volume is that much. I need to subtract the volume of my marbles. So we're going to do 3,500 minus 1,675. All right, we get 1,825 is the remaining volume inside the box. 1,825 cubic millimeters of remaining space inside of that container. And that's it for that one. That was a fun one. All right, last one. Let's see if this one's just a simple one or, ooh, I like it. Hemisphere with a radius of 18, and then removing the hemisphere with a radius of 14 inches from it. Oh, so this is kind of like, it's creating like a bowl. Okay, wow, this is kind of a weird one. All right, so first of all, a hemisphere is only half of a sphere. So like, if we have a sphere and you cut the sphere in half, that's a hemisphere. And then it's kind of a weird. All right, so I'm going to show you what this looks like. Okay, so imagine this is a ball, right? Now, obviously, what I just did was two-dimensional, but we cut that ball in half. Okay, and it says the diameter. No, it's saying the radius. Sorry, not the diameter. It's saying the radius is 18. I guess I gotta move that out of the way. All right, so it's saying halfway across that is 18. So all the way across that bowl would be. Sorry, it's just a ball at this point, half of a ball. It's saying that's 18 inches. But what I'm doing is I'm cutting out. I'm cutting out another one with 14 inches. So like this one right here, from here to here is 14 inches. So from here to here is 18. From here to here is 14. So essentially what I have left is kind of like a bowl. So that's what we're trying to figure out. We're trying to figure out what is the volume of this part. So it's kind of a weird question. I like it though. So let's move. I need to move my face somewhere else. So I'm out of the way here. All right, so we want to go back up to this formula here. So we're going to get rid of this, get rid of this. Okay, and we want to go back to this one. All right, so the formula for finding the area of each hemisphere is the same. So all I need to do is go in here and I'm going to do 4/3. I'm only going to write this once. So 4/3 pi, so 3.14 r cubed. So in this case, it said the radius is 18 for the first one. Okay. Once I figure out what this is, I'm going to divide by 2. Because this is the formula for a whole sphere. I only want half of it because it's a hemisphere. And then the formula for the other one is going to be the same thing. But instead it's 14 instead of 13. Or sorry, instead of 18. Okay, and again, same thing. This is only a hemisphere as well. So I'm going to divide that by 2. So all I'm going to do is go into Desmos, and I'm going to figure out what the volume of this is. Okay, so that is that number. So I'm just going to, before I even go to the next thing, I'm going to just divide that by 2. 24,416 divided by 2. So that's 12,208. Oops, I forgot the 0.64. So 12,208.32. So the volume of so I'm just going to do that. I'm going to skip the part where I write out what that one is. So 12,208 I forgot the number already. 0.32. So that's the volume of the bigger one, the 18, radius of 18. So now I'm going to go in here and change it to 14 to find that radius. And that's this number. Okay, so now I'm going to take that number and divide that by 2. So I'm going to go in here and change this to 11,488.21. We'll put a couple 3's in there. All right, so the volume of that one, and remember, here's the volume of this sphere. We want a hemisphere, which is half of it. So 5,744 point, we'll say 1, 1. We'll round it to 1, 1. 5,000, I already forgot the number. 5,744.11. All right, and then we're just going to subtract those two to figure out what the volume of this piece is. Because we have the volume of this minus the volume of what that big chunk we're taking out. So we're left with a bowl, essentially. All right, so yeah, that's not my number. 12,208.32. I think that's my right number. Yep, 12,208.32 minus, and then I'm subtracting this number, so minus 5,744, and then we rounded it to 0.11, or I did. All right, and then we get 6,464.21, 6,464.21, and in this case it is cubic inches, because again it's still volume. And that is our volume. All right, that was a fun one. Interesting question. All right, and that is it for lesson 8 notes. In lesson 9, when we get to that one, and I'm going to move some things around here. In lesson 9, we are comparing the volume of cones, cylinders, and spheres. So that's kind of an interesting one where we compare like how they relate to each other. So, for instance, cylinder, if you take the volume of a cylinder and multiply it by 1/3, you get the volume of a cone, which is kind of interesting. But anyways, that is for another lesson. So if you guys have any questions about lesson 8, feel free to reach out. You can book some time with me if you would, if you need help. Otherwise, have a fantastic rest of your day.